This is the picture that you might have seen in your textbook. Okay, so this is how alpha particle behaves when it goes and hits gold foil. Okay, so we will also discuss that as well. Let's understand some important points. In 1911, Ernest Rutherford performed alpha particle scattering experiment, or it's also called as gold foil experiment. So here in the first line, there are two main points that we need to understand about is alpha particle and why he chose gold only. Why not any other metal? First, what is alpha particle? So an alpha particle is just helium nucleus with 2 plus charge and a 4 unit of mass. Say, we know that helium is having 2 protons in its nucleus, so atomic number is 2, and it's having 2 protons plus 2 neutrons in its nucleus further, and it makes 4 unit as its mass. 2 electrons are outside the nucleus revolving around it. So if we remove both of these electrons from the helium atom, so it will convert into 2 plus and 4 unit is there also, mass is intact because we have not removed any neutron, we have not taken out any proton from the helium atom. So what we have taken out is just electron, 2 electrons, a couple of electron is being taken out. So now without any electron, this is just a helium nucleus, that's called as alpha particle. That's called as alpha particle. So this is the notation for alpha. Okay. Okay, so these alpha particles, so you might be thinking that what could be the source of alpha particles? Yes, source of alpha particle is radioactive element. Radioactive element that emits out alpha particles can be the good source of this alpha particle beam or alpha particle rays. Okay. Got it? So it's having a mass of 4 and charge 2 plus. Now Rutherford selected gold. Rutherford selected a gold foil. Okay, so he doesn't choose iron, he doesn't choose lead, or he doesn't choose any other foil, but he chose gold foil because there's a good reason for that. Because gold is the most malleable metal. Okay, so malleable means that can be drawn into thin sheets. The thickness of the gold foil was just 1000 atoms. What were the observations when he directed alpha particle beam onto a gold foil? The first observation was most of the alpha particle passed through the gold foil undeflected. That means most of the space inside an atom is empty. So this postulate, the very first postulate, it nullifies the claim made by J.J. Thomson that positive charge is separate throughout the atom. Had been the case that positive charge is separate throughout the atom, all the alpha particles would have been thrown back if the positive charge is separate, if the positive charge were separate throughout the atom as described by J.J. Thomson. But that's not the case. Some of the alpha particles deflected by small angles. Some of the alpha particles were deflected by small angles. Look at these small angles. So these are the alpha particles that pass through the gold foil undeflected. So they make up about 99.9% of the alpha particles that were hit onto the gold foil. So this is huge. Third postulate or third observation was 1 out of 12,000 alpha particles deflected by an angle of 180 degree. Look at this one. The alpha particle that is shown in the middle, this one. So this alpha particle approached towards the center of the atom. Okay, but this alpha particle was thrown back, or this was deflected back with a huge speed and with an opposite angle. So if it approaches nucleus, or if it approaches the center of the atom at an angle 0 degree, it was deflected at an angle 180 degree. Okay, so in the reverse direction. So we will come to this, why it happened. Now some conclusions drawn out of these observations are, the first conclusion is that most of the space inside an atom is empty. So that is about 99.9%. That's empty. Nothing is there. Second, there is highly dense positive charged mass at the center, occupying very small volume. It is highly dense because all the mass of an atom is concentrated in the nucleus. That's why its density is huge. It's positively charged because protons are there inside the nucleus. The protons are positively charged. And it is at the center, occupying very small volume. Okay, so it's 0.01% of the volume is occupied by nucleus. So on the basis of different observations and their conclusions, Rutherford put forward his model of an atom, which is called as Rutherford's model of an atom. So this model looked like this. What were the main points or main postulates of these of Rutherford's model? Let's understand that the first postulate says that there is a positively charged center in the atom called as nucleus. So nucleus was discovered by Rutherford. Look at this. This is positive charge center in the atom, that is nucleus. Second one, nearly all the mass of an atom lies inside the nucleus. So obviously, so nucleus contains protons and neutrons, which were later discovered. So this constitutes all the mass. Nearly 99.99% mass of an atom is due to protons and neutrons. Because mass of electron is very negligible, so it is not considered to contribute to the overall mass of an atom. It's very negligible. Then the electrons are outside the nucleus in extranuclear space. The space that is outside the nucleus is called extranuclear space. So in that extranuclear space, electrons are revolving around the nucleus in circular orbits, or those are called as shells. The electrons revolve around the nucleus in well-defined orbits. So we can consider orbit as path of the electron, path of an electron. Okay, so this is well defined. So that means electron has a predefined path to revolve on. Fifth point is that electrostatic force. Okay, so my dear, please concentrate on this term. It's electrostatic force. Electrostatic force is force between charged particles. So there are charges inside atom. Nucleus is positive charged, electron is negatively charged. So there is force of attraction between these two charges. So that force of attraction is called as electrostatic force of attraction. So that's force of attraction between two charged particles. That type of force of attraction is between negative charged electron and positively charged nucleus, is balanced by centrifugal force of the revolving electron. So attention please, look at this. So there is a force of attraction. This is electron. There's a force of attraction between nucleus and electron. Nucleus being heavier attracts electron towards itself due to electrostatic force of attraction. But instead of getting attracted towards the nucleus, electron is not falling into the nucleus because it is maintaining a force because of its speed, or because it is revolving. Okay, so it's maintaining a force that's called centrifugal force. Centrifugal force is just like this. Okay, so centrifugal force is away from the nucleus. That's centrifugal force. And this centrifugal force is developed in bodies that are revolving in circle or circular orbits. If this centrifugal force and this electrostatic force is balanced, that means this electron will definitely and successfully will continue revolving around this nucleus. But if any of these forces is unbalanced, like if the electrostatic force is greater than the centrifugal force, the nucleus will start attracting the electron towards itself, and ultimately the electron will definitely because of the increasing electrostatic force, will fall into the nucleus. That means the atom would, in that case, will be unstable and it destroys. But if centrifugal force is increasing, or it is more than the electrostatic force, in that case electron will leave the predefined orbit and will not be found in the orbit. In that way also there is instability in case of an atom. So now let's understand drawbacks or the failures of Rutherford's model, or drawbacks of the model. First drawback is that Rutherford could not explain stability of an atom. Now, what is stability? Force. The balance between electrostatic force and centrifugal force is definitely stability of an atom. Here we go. It is said that a charged particle like electron in circular motion must lose energy, and that consequently, if it loses energy, its distance from the nucleus, means the radius, we can say, radius of an atom, distance from the nucleus, it will start decreasing because of the greater pull from the nucleus. If it start decreasing, okay, so if it start coming closer to the nucleus, the radius will decrease, and ultimately the electron will make a spiral path into the nucleus, or will make a spiral path and fall into the nucleus, just like this diagram. If this electron is losing energy, as per the principles of physics, a charged particle in circular motion definitely must lose energy. If it is losing energy, since it is charged particle and it is also moving in a circular motion, if it loses energy, then a spiral path will be its direction after some time, and it will quickly, within a blink of an eye, it will fall into the nucleus. A falling of an electron into the nucleus will make the atom destable, or will make the atom to collapse. But that's not the case. Atom is structurally very, very stable. If atom collapses, matter will collapse. If matter collapses, this universe will collapse. But that's not the case. So he was just, as we can see, this universe is quite stable, able to explain how this electron is able to move successfully around the nucleus without falling into the nucleus, or without collapsing into the nucleus. And this drawback was cleared, or this drawback was answered by the next model, which is Bohr's model. We are going to discuss that one in the next class as well. So if you have any kind of question, any kind of query regarding Rutherford's model, or the previous one, J.J. Thomson's model, please and please drop your questions in the comment box. I'll make sure that I'll answer all your questions on time. And please and please do subscribe my channel to support me, so that I can get motivated more and more to deliver more and more chemistry for all of you. So we will be meeting in the next one. Till then, keep learning. Bye bye. Take care and see you in the next one.